Did you know that you can animate objects with code in Storyline 360? That's right, you can. With GSAP, the Greensock Animation Platform. Join me and learn how to use this powerful JavaScript library to control your slide elements and create some amazing presentations and animations or some customizable interactions that you wouldn't be able to achieve with the defaults Storyline has to offer. GSAP, or the Greensock Animation Platform, is a JavaScript library commonly used by web developers to add smooth and dynamic animations to web projects. Now, GSAP offers a series of tools and functions to control the movement, the rotation, the scaling, the fading, and the sequencing of HTML elements with precision and ease. But don't worry, you won't have to install anything, because GSAP is already integrated into Storyline 360, making it easier for us to dive right in and start tinkering around. Now together, we will explore some techniques you can use to bump your e-learning modules up a notch by creating polished and professional-looking interactions and animations. We will focus on practical examples, which you can recreate and use in your projects straight away. Each new video will build on the previous one, allowing you to create increasingly complex projects. Even though we're going to be as practical as possible, we will still explore why our code works like it does, so you can understand it and adapt it to your own present and future project needs. So cast aside the dozens of triggers and the tangled motion paths, and save some time by using GSAP to animate your slide objects. Not only will you add new skills to your inventory, but you can also become increasingly comfortable using JavaScript and GSAP in your projects in the future. So whether you're a seasoned Storyline veteran looking to level up your skills, or an intermediate user who wants to delve deeper into the world of JavaScript, variables, and Storyline integrations, this series can become your secret ally for creating dynamic and engaging e-learning experiences. If you think this is for you, join me in this exploration of what's possible with GSAP in Storyline. Before we dive in, please make sure you have Storyline 360 up and running on your computer. You might also want to prepare a few images or assets that you can use in case you want to follow along, which I recommend you do so that you can get into the habit of typing and working with code in Storyline. Now, this next step is optional but highly recommended. I suggest you use a code editor to write and edit your code. You'll see that I use Visual Studio Code, which is a free code editor made by Microsoft. But you can use anything you want, such as Sublime Text or even a website that allows you to edit JavaScript code, such as CodePen. I say that this is optional because you could go through this entire series with just the default Storyline code editor. But just know that the code editors I mentioned have some important features that the default Storyline code editor does not have. It's important for us to have syntax highlighting, which means that different things will be displayed in different colors, and that way we'll know what each bit of our code represents. It's also important that we have error and syntax checking, so we don't run the risk of our code not running because we forgot a semicolon somewhere. So that covers the tools we'll use. Now the next thing is prior knowledge. You should be familiar with how to get and set Storyline variables using JavaScript. If you're not, I added the link to that documentation in the resources. I also added a few resources for JavaScript variables and the GSAP documentation website, just in case you get stuck or want to go deeper into some of the concepts we're covering. Now, with that said, you're all set. Let's go and learn how to animate some Storyline elements with GSAP. Here's what we're gonna do in this series. We're gonna start off by learning how to change the position of a Storyline element in a slide. Then we'll move on to talking about special properties such as repeats and yo-yos. We'll then talk about transparency and opacity, and controlling these values with the press of a button. We'll animate scale and talk about transform origin points. We will cover rotation and all the different ways you can rotate an object using GSAP. We'll talk about Stagger, which is a way of sequencing our GSAP animations. We'll talk about GSAP timelines and see how we can control individual animations while still having them play in a sequence. We'll see how we can control our GSAP animations with interactable storyline elements such as sliders. We'll then move on to some practical examples which you can use in your projects. The first one is a counter similar to a slot machine, which we will animate from scratch. Next, we will make it so that we can explore this timeline by dragging our slider. Then, we'll create a card flip animation. Next up, we are going to use GSAP to animate number values. We'll talk about some of the resizing issues you might face in GSAP and possible solutions. We'll spin this wheel of fortune to a random number. And then we'll combine everything to shatter some glass. So there you have it. Now let's dive in. I have created a storyline document and went to the Design tab and changed the slide size to 16 by 9 with a width of 1366 by 768. Set it as the default size. Click OK. I'll be using this slide size throughout the course. Let's click into this slide. I'm gonna delete these next and previous triggers from here. Then what I did is I created a background with a nice little road here to help us visualize the animation. A car, it's the image of a car, and the button move car, which has two states, a normal state and a hover state. I'm going to create now an execute JavaScript trigger for this button when user clicks this button. I'll just leave it blank for now. And now we're gonna try and figure out what code we need to put in here in order to make the car move when we press the button. In order for us to move our car, we'll first have to write some code that will help us select the object and then move the object. Now, if our car were an image on a website, we would use GSAP to do both of these things. But since it's not, and Storyline has a more obfuscating way of storing its elements, we're going to just focus on the second part, and we're going to find out what code we need to use in order to move the object. Then we'll come back to the first part and see how we can select it. So I have opened the GSAP website, and we're going to go and see the Resources tab. Click here, and just under Getting Started, here we have Installation. So under Getting Started, we have Installation, but we don't need to install the plugin since it already comes with Storyline. We're just going to click on the Getting Started guide, which will have some useful tips for us in order to understand what GSAP can do and see how the code looks like with some examples. And now I will keep referring to this throughout our videos, and I suggest you go there yourself in order to check out what GSAP can actually do. So here we have a nice animation with GSAP. I'm going to click here on Rerun and see what the animation is. And the line of code we'll be using is this right here. I'm just going to copy it. So what does it do? It's telling us that we are using the GSAP library. And from that library, we are using the to method. Using this method, we will animate our target element, which is our box. And we will bring this element to a position on the x-axis of 200 pixels, from whichever position it might be in initially. Now, what's cool about this is that we can see the code in action by clicking on this button right here, which will take us to CodePen. So this is the JavaScript, the HTML. Let's see it in greater detail by clicking on the fork button, and it will bring us to codepen.io, which is a site which has HTML, CSS, and JavaScript code snippets that you can run and tamper with. So we're going to set the X to 1200 just so we can see what it does. So it's going to start from about here and go up to about here. Let's click on run, and it takes a while. There we go. I overshot a bit, but that's okay. So as you can see, we can modify the parameters here because in Storyline, in the new update, you can preview it in the browser, but normally if it's a big slide, you would have to preferably export it as a web version or as a SCORM package, and you have to export it every time to check out the triggers. Now, as you can see, the animation doesn't have a specified duration. Its default duration is 0.5 seconds, but we can enter a custom duration for it. So what we're going to do now is write down a duration parameter. So I'm going to just write duration here. And let's just input 4 seconds and see how it performs. And now the box will move from left to right over 4 seconds. So now that we know how this works, I'm going to copy this into my code editor. I'm going to create a new file, car.js, a new JavaScript file. I'm going to paste this line here. Now, all we need to do is figure out how to actually select the car using code. Now, in order to do this, we will use the car's accessibility property. Its accessibility name is currently car. So I have entered car and enabled accessibility. And once we export the project, this is my exported project. If I right click here on the gray edges and click on inspect, I will open up the elements pane. I'm using Google Chrome, but this will look the same in whichever browser you use. If I hover over these elements and click on the white arrows, I will be able to select different elements within our slide after Storyline has compiled my project. So I'm just gonna keep on hovering over here. I'm gonna have to open a lot of these arrows in order to get to my actual car. So if you're gonna try this, you need to have patience and just keep opening these arrows until there it is. There it's just here. So I'm now hovering over my car. As you can see, there's a lot of jumbled text in here. This is basically the identifier of the car. It has a data model ID. You can see the accessibility text we inputted under data-acc-text. It has a lot of other properties such as its transform origin, its rotation. Its Z index. We're gonna talk about all of these later on. But first of all, we can see here that it has a model ID, but it's a bit encoded. It's like a cipher, and this will just get regenerated each time you export the project. So for example, if you add elements to the slide, perhaps you delete the car, perhaps you have another car, a blue car that you want to add into our project, this identifier will change even if you click, I don't know, replace the image of the car. So if you do any modification to the slide, this slide ID will change. So the only viable option for us to select it is to use the accessibility text. Now, there are some users who have had success by using elements group order in order to select this, but it's a lot harder. So we're going to just rely on accessibility text for now to select our animation elements. So one user on the Articulate forums, Math Nutemans, figured out that you can select Storyline objects by using JavaScript code and their accessibility text property. So that's what we're gonna use as well. So what does this code do? Well, to read it, we will first start from to the right of the equal sign. So it's gonna search the document and it's gonna ask it, hey, can you please retrieve every element. That's why we're using the query selector all. So it's going to retrieve every element that has the following property. And the property is written between the two parentheses. And the property is an element which has the data accessibility text equal to, and we're going to input our accessibility name. Currently, it's set to my name. In our case, it's going to be car. Please search this document and retrieve every element that has the following property. The property being that its data accessibility text is equal to my name. And once we have retrieved that, we're going to store it in a variable called myElement. So this is now stored in the myElement variable, and we're going to use this to perform our animation. We're going to use this in the GSAP code in order to animate our car element. We're going to move to the code editor and paste this in here. Now we need to edit our code a bit. So instead of my name here, we will have car because our element has an accessibility value of car. And we can leave it as my element. We can define this value as car. But in order to be as specific as possible, I'm going to name it animation target so that we know that this is the car element is the target of the animation. So now we are going to replace this target with animation target. This means that this code will apply the animation to the car. Let's put it back to 200 on the x-axis, and let's write some comments to know exactly what we're doing. So this is the code to move the car, and this is the code to select the car. We're going to copy all of this into our execute JavaScript trigger. You can see now the difference between the code editor and the JavaScript editor, which comes with Storyline. So in our code editor in VS Code, these values are much more visible. You can see what this variable is. You just have more clarity. And now we have an action that should happen when the user clicks the button. We're going to publish just to check. Our car should now move on the x-axis. So this is the x horizontal axis, and this is the y-axis, the vertical axis. Since we gave our animation a value only on the x-axis, the car should move to 200 on the x-axis. Let's press the button, and over 4 seconds, the car moves to 200. So what we're using now to select the car is the document query selector all, which, if you look at the JavaScript documentation, will select all the elements on our page with the accessibility text of car. We can use just query selector and it will select the car, only the car. Let's exemplify this by duplicating the car. Remember, it still has the accessibility name of car, even though it's called car1. Just to make it more different than the other car, we're gonna recolor it in green. Let's rotate it, let's flip it. Now, if we publish the course, now that we've published the course, we will see that both cars move to the X of 200 if we press the button. That's because both cars are affected by the animation. Both cars are selected because we use the query selector all property. So what happens when I use only query selector? I updated the code in our JavaScript trigger. Let's click OK. And now if I publish, you will see that if I press the button, only the first car moves. So it takes only the first element with the name of car, depending on the order of the elements from the bottom to the top of the timeline here in Storyline. So far, we have explored the fromTo method in GSAP. We have used it to move our car from a position we placed it in on the slide to a position we defined using code. Now, GSAP alongside the to method has other methods we can use to animate in Storyline. The fromTo method, and the set method. We're going to explore all of them, starting with the from method. Okay, so let's see what the from method actually does. I will delete this second car, and I will modify the code to use the from value. So what will happen is the car will move to this point from a random value we choose. So I'm gonna move it from an x of minus, let's say 600. That will mean that the car is way off screen. And over 4 seconds, it will move from way off screen over here to this position. Let's not forget to copy the code, publish the course. If we press the button now, the car will move from off screen into the center of the screen where its initial position is. Now this is similar to a fly-in entrance animation. Now let's see what the fromTo method does. Let's copy this line of code, paste it into our, or you know what? I'm gonna show you something. We can save this code for later without deleting it by pressing Ctrl and /. This will comment out all the code and it will be invisible to the program. We're gonna paste the new line in. We're gonna make sure that the animation target is the animation target. And from an x of minus 40, let's make it 40. We'll move it to an x of 200. We'll delete these fill values from here because it will be impossible for us to change the color of our PNG car. Let's paste the code into our editor. And you know what? We're gonna move the car here just so you see the movement. So it has an x of 1065 and it will move when we press the button from here 40 to about here 200. So let's publish the project and see. So the car is here. If we press the button, it moves from here to here. And of course we can also set a duration of 5 seconds, let's say. Let's just paste the code again, publish again. If we press move car, you can see that the animation happens as expected. Now, what's not so nice about Storyline is that you always have to republish if you made a modification to the code, which is why sometimes it can be useful to just use a code pen provided by GSAP in order to test out your animations. Now let's move on to the GSAP set method, which, as you can see, instantly moves an object from a position to another position. So we're gonna delete this and press Ctrl / again to uncomment our code, move it up, and we're just gonna replace this with set and an x of 600. We don't need a duration because the set function does it instantly. Paste the code into our JavaScript editor, and if we publish, we can see that the car is instantly teleported to our new position. Let's refresh. Instantly moves to our new position. So the only thing left for us to do now is to try and move the car by a certain amount each time the button is pressed. So each time the button is pressed, the car moves a bit. So how do we do that? If we check the GSAP documentation, we can scroll down a bit here on the Get Started page and see that this is it. So If we look here, we can see that we can increment a value. We can use relative values for our animations. This is like having a motion path with a relative start point. So this will move each time we press the button, the car will move like so. Let's just undo that real quick. So I'm gonna just set this back to a to method, and we're gonna animate, we're gonna animate by plus 300, that's too much, plus 100 every time the button is pressed for a duration of, let's just make it 2 seconds. Copy this code, paste it into our storyline. I'm gonna publish, and now each time I click the button, oh, something's wrong. I think I need to put it as plus equals. Let's see. Yes, this is what I forgot. So instead of just plus, it's plus equals. Gonna replace the code, publish again, once, twice, 3 times. As you can see, we got the result we desired. Sometimes you need to experiment with the code, but eventually you will have greater control over this. Let's talk a bit about easing in GSAP. What is easing? It's one of the coolest features of GSAP actually, because they are essentially predefined mathematical functions that control the acceleration or deceleration of an animation over time. So this is what I mean. This is a linear ease. It all goes smoothly, so the animation is very smooth from one end to another. And this has a bounce out, so a bounced out ease, which, as you can see, has a little bounce at the end when it rotates. So it can give an animation character, perhaps give them a more natural look or a more polished look. GSAP also has this curve here, this ease visualizer, and we can visualize the animation curves for each type of ease. We can click on this green arrow, and we can also select different types of eases, so variations for the same ease. There are many types of eases which we will not be covering. I'm just gonna cover for example, let's focus on the bounce, and implementing them is just as easy as copying them from here and pasting it into our GSAP code in Storyline. So for example, if I were to paste this, if I were to copy this into Storyline, I'm just gonna put it on our red car here, click publish, and if we view the project now, if I press this, we'll see that it has a little bounce when it's moving, so it doesn't move linearly like it used to. To see it better, let's just fork this code pen offered by GSAP, and we can give the purple, for example, not a rotation parameter, but an Y. Let's drop it for plus equals 200 pixels. Let's see how that looks. Oh, need to put this in between quotes. There we go. Let's actually make it 50 so that it doesn't overextend here. I'm just gonna click run. Okay, it's too small of a value. Let's put this at 100, and we're gonna do the same for the linear as well, just so you can see what I mean. So we're gonna have a value of plus equals 100, and it has an ease of none. Let's see the difference now. So as you can see, this bounce animation truly looks like an object is falling. So if a box is falling on the ground, it bounces and then falls again, while this linear just goes from A to B in a linear fashion. So if let's actually remove the repeat delay from each one. So we don't need a repeat delay. Let's run it again. Okay, now you can see it better, the bounce and the linear animation. So this is a trick that will help you create more natural looking animations perhaps, or just make them look not as boring, for example, as the linear one. So for this one, we will make an astronaut float. Now, I have created a new scene with a new slide. On this slide, I have put a background and an image of an astronaut. So our objective will be to make this guy float up and down. In order to make this astronaut float up and down, I'm gonna first create an execute JavaScript trigger, which will execute when the timeline starts on the slide. So now let's see how we can make the astronaut move. I'm gonna first right click it and set its accessibility name to astronaut. Then I'm gonna head to the code editor and create a new file, which I will call astronaut.js. Save this file. I can save it right here or just Control S. And I'm gonna copy this part, which will allow me to select the astronaut. So I'm gonna change this accessibility name from car to astronaut, and also little comments. Then I'm gonna copy this animation. Again, we're gonna change car to astronaut here. Notice that since I've given this variable the name of animation target, I don't have to change it to astronaut or something. It's clear what the variable does. It's clear here what variable we are targeting, so it's all good in that regard. I'm gonna delete these two properties. We can leave the duration as 2 seconds, and we're gonna move it on the y-axis for up and down movement. How about, let's leave it at 100 pixels, copy this code, paste it in our JavaScript trigger, and we're gonna publish this scene. And now, as we can see, the astronaut moves down by 100 pixels. Oh. Now the question is, how do we get the astronaut to come back up again in order to simulate a floating movement? Well, you see, if we go to the GSAP documentation, we have some special properties here on the Get Started page, one of which is the yo-yo property, which means that every other repeat, the twin will run in the opposite direction, like a yo-yo. So by default, this value is false. We can enable it by saying yo-yo. That's all we need to do. Copy this code, paste it, publish our course, and something's wrong. Is it the comma? It's not working. Maybe we should also add a repeat, since it says here that on every repeat, the tween will turn in the opposite direction. So we're gonna add the repeat special property. This happens sometimes. This is what coding is. You gotta troubleshoot and figure out why things aren't working. So this animation will repeat 2 times. Let's copy the code, paste it in the trigger, publish our scene. So now it works. As you can see, it was based, the yo-yo parameter was based on the repeat property, so it's dependent on the repeat property. Now we have a problem because as you can see, the animation only repeats 2 times, 1 and 2. So what we want is for our astronaut to seamlessly continue this movement forever. So in order to do that, I will change the repeat value from 2 to -1. That means it will repeat forever. Let's just paste it into our JavaScript trigger and publish this course for a demonstration. There we go. Now we will see that this movement repeats forever, and that's great. Now there are other ways in which we can get this astronaut to move, other ways than telling it to go plus 100 pixels on the Y. We can also move it by a percentage. So in order to do that, we will change this from y equals to y percent colon minus 5. So what am I doing here? I'm basically moving the element by minus, let me get this out of the way, minus 5% on the y axis. So when in doubt, always comment your code so you know what you're doing. And I'm gonna also save it. Okay, it out. There you go. Now the movement is very, very close to what we want. So you might be saying, okay, 5%, but 5% of what? I have 5% of the, should I put here as a border? It's 5% of the total of the image, in this case, since we're moving it on the y-axis. Now, we can demonstrate percentages by, let's set the y% to minus 100. So it will move, now the astronaut will move on the y-axis for a distance equal to its height. Okay, I'm gonna publish this. So as I said, this moves upwards based on its height. If we change the y% to x%, you will see that the movement is much more, doesn't move as much because the x-axis of this image is shorter, so it will move like this. There you go. As I said, now the movement is much more fluid, or not fluid, I mean it moves a shorter distance because the x-axis is shorter than the y-axis. So those are a few things to keep in mind when using percentages. Okay, we're gonna set this back to y%, and we're gonna set the value back to minus 5 because that was a fluid moment. And let's also give it an ease of power 1 seems fine. And I want it to be in and out so it doesn't feel janky when it animates. Okay, remove the outline, publish the course, and this should be exactly what I want. A smooth floating motion up and down, just like this astronaut were floating in space. Now we will talk about opacity. I have created a new scene with a new slide. On this slide I have an image of a ghost, a background, and the image of a ghost has the alternate text ghost. Now we have here a button, 2 states, which I will use to reduce the ghost's opacity. Now when we talk about opacity in Storyline, if I right click and go to format picture, opacity is basically the inverse of transparency. So here's how to think about transparency and opacity. So transparency in Storyline. When the object is fully visible, transparency is at 0%. And as it becomes invisible, it goes from 0% to 100%. And then when transparency is at 100%, the object is not visible on the slide. On the other hand, opacity goes from 0 to 1, but in the inverse direction. For example, when opacity is 0, the object is invisible. And as it goes from 0 to 1, so 0.5, 0.7, etc., and reaches 1, when the opacity is 1, the object is fully visible. So I will use the terms opacity and transparency interchangeably, but just know that I am referring to the opacity value as defined by GSAP. Now we will add an execute JavaScript trigger to this button. When the user clicks on the button fade, something will happen. What will happen exactly? Let's go to our code editor, create a new file, ghost.js. Now you don't need to create new files for every exercise. I just like to keep them separate. You can of course write all the code in one file, but it's gonna get messy real fast if you're writing for several projects or several slides. Let's select the ghost. We're just gonna change this to ghost. Maybe copy this between right here. Let's also not forget to comment our code, just so we know what we're doing. So we are selecting the ghost, and here we are fading the ghost. So we're gonna delete all of this, maybe delete all of this except for the duration. So we can do this several ways. We can use gsap.set to set the opacity immediately from 1 to 0, or we can use 2 and set the opacity over a certain number of seconds. I'm gonna do it with gsap.to, and over 2 seconds, let's affect the opacity, set it to 0. Copy this code, paste it, and let's publish our scene. If we push this button now, the ghost will fade completely over 2 seconds, just as we intended. So this is basically a fade animation, which you can also find in the exit animations in Storyline. So far, so good. Now let's bring the ghost back. Let's duplicate this button, and we're gonna change the name to Boo, since we're gonna have the ghost suddenly appear. And in order for the ghost to suddenly appear, let's just separate these actions. So fade completely. And here we're gonna have the code for Boo. So we are making the ghost appear, not fading the ghost. So we're gonna use set, as I said last time, remove the duration parameter, and set the opacity to 1. Copy this code, place it in our, let's actually rename the button itself to button Boo, and replace the JavaScript here, publish the scene, and now we will see that I can fade the ghost, and we can make it appear again. Fade, then Boo. Very nice. So far, so good. Now, we are gonna do one more thing. We are gonna fade the ghost bit by bit. So every time I click this button, let's first rename it. Fade progressively. Fade bit by bit. That should be clear enough. We're gonna fade the ghost. So first time we press the button, its opacity will drop, then it will drop some more, then it will drop again and again and again until the ghost is fully faded. Oops, let's bring it back. So how do we do that? First, let's just delete the JavaScript from here so I know which button to affect with our code. Move to the editor, copy this. So I updated the comment. I updated the comments. So before we move to the editor, we need to create a variable that will store our current opacity. So let's create a variable. We're gonna call it of type number, and we're gonna call it storyline underscore current ghost opacity. Okay, with a value of 1. And you know what? We're gonna also, where is it? We're gonna also expose it right here. So current, let's change this text to white. Why not make it, let's make it a bit more yellow. So current ghost opacity is SL current, and it should be now, it should be 1. Okay, and now let's move back to the code editor. Let's just add a bit more space here so we know that these are different sections. We can also close these off. So, but we'll leave it as is and just move this down. So we got the ghost. Now we're gonna get the storyline variable we created. So get the current ghost opacity. To do that, we need to get the player. So player equals get player. And from we need to define a new variable equals, there we go. Now we got the value. Now let's decrease. What do we need to do? We need to decrease by a certain amount. So we're gonna do current ghost opacity equals current ghost opacity minus 0.1. So basically 10%. We're gonna decrease by 10%. And we're just gonna move to the function, and here instead of opacity equals 1, we can set the opacity to a variable. In our case, we're going to set the opacity to current ghost opacity. And then we are going to actually set the variable, the ghost opacity variable, back so we can see how it changes in storyline as well. So we are going to player set, let's first comment, set current ghost. So we're going to modify the variable in storyline. So player.setVar current ghost opacity, we're going to set it to current ghost opacity. So we are selecting the ghost for our GSAP animation to run. Then we are getting a ghost opacity value we defined in storyline. Then we are decrementing this value by 0.1. We are running the animation to fade the ghost by this value, which will be 1 minus 0.1, 0.9. So we're setting the opacity to 0.9, then on the next button press to 0.8, and so on until we get to 0. If you like, you can think of it as this is 10%. So we're reducing the opacity by 10% each time we are pressing the button. Then we are setting the variable back into storyline. We are setting the variable so we know what value the opacity is currently on, and so we can have it as a reference for the next time the button is pressed and we have to run the code. If we were to set it here, the opacity will always be 1 if we don't do this. So each time the code is run, the first time it will work and the next time it will not work. So we're going to copy this code to the JavaScript trigger, publish, and let's see if this works. So we have our current ghost opacity equals 1, and if we press the button, 0.9, you can see it has already begun to fade a bit, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1, and 0. But if we press it again, it's going to be minus 0.1, minus 0.2, minus 0.3. We're going to fix that. But for now, it does what we wanted. It fades, and it fades immediately by 10%. You can also animate this. We are currently using the set method of GSAP. You can use the to method, give it a duration, do whatever you like. So the problem we're now facing is that this value goes lower than 0. So what we need to do is basically constrain this method. So we need to constrain this method so that the animation runs only when the value is above 0. So how can we do this? We will wrap these two in an if statement. So we're gonna write if current opacity is greater than or equal to 0, then we will place these brackets. We will copy this code inside our bracket. So if we highlight the brackets, you see where it ends. And this bracket ends here. This is also one of the advantages of using an IDE, a code editor, rather than using the default storyline code editor. So let's also add a comment. Only runs when or equal to 0. Let's copy the code again, paste it into our trigger, click on let's publish and see if our approach worked. So we're gonna fade it and it doesn't fade. It does what we wanted. So we can still use the other buttons. Fade, it doesn't do anything because it's already at 0. Boo, it suddenly appeared. Now you see, since we have this opacity value, we also need to add it to our other buttons as well. So for example, we need to add ghost opacity to our boo trigger, so we can make it 1. Current opacity, we can set it to 1. And we need to add this to our fade completely button so that it sets it to 0. Now we can either do this by creating a storyline trigger, or we can add it to the code, but we will need to add the references to the player as well. So let's do it by code. We will just set it to 0 directly. We're going to paste it into our first, oh, no, not this, to our button fade. And then we're going to also add this to the boo button, but we're going to make this 1. Don't forget to add the references to the player. Copy all of this. Go to the button boo, and now it should all work and update as intended. Let's see. So if I fade it, the current ghost opacity goes to 0. Boo, it's 1. It decreases progressively when I press the third button. If I boo again, it will go back to 1. So everything is working as we want. Now we are going to talk about scale. I have created a new scene and a new slide. This slide has an image of a pair of lungs and a background. Now I have given the lungs the accessibility name lungs. What we're going to do is we're going to animate these so it seems like they are breathing. And to do this, we're going to animate their scale. So let's go. We're going to set up an execute JavaScript trigger when the timeline starts. And for the JavaScript, let's move to our code editor, create a new file, and we're going to paste. We're going to use the code we created for moving the astronaut because it already has a lot of the elements we need. Now we can rename this, all of these occurrences of astronaut, by pressing Ctrl H and typing lungs. Hit enter. Why doesn't it work? Replace all. There we go. And save it. So we have renamed all the astronaut references. Now what we are going to do is we are going to delete this since we're not affecting the position of the lungs. We're just going to affect the scale. And we're going to set the scale. Let's set it to 0.95. So we're going to shrink the lungs for a bit and see what the effect is. Just gonna paste the code into the JavaScript editor, publish this scene, and there we go. It looks as if the person is breathing through their lungs. Now, this effect can be very cool for your presentations, and it can take them to the next level, so to say. Now, we are going to explore scaling a bit. So how about we comment this value to have it stored? And we're gonna also explore other scaling options. So we can also scale the element only on one axis. So scale X, and I'm gonna set a value of 2. So this will scale only on the X axis. Let's just paste the code here, publish, and as you can see, this only scales on the X axis, and I can do the same for the Y. Copy, paste the code. So this is just one cool aspect. You can scale on individual axes, and I'm going to give this image a border in order to illustrate the transform origins. Now, what are transform origins? Imagine for a second you are placing a piece of paper on your desk, placing a finger on it, and you're trying to rotate it around the finger. Now, wherever you put your finger, that is the transform origin point, and it will rotate, scale around that point. Now, for example, I have found this code pen by user Shaw, which perfectly illustrates this point about transform origins. Now, as you can see, here we have some squares. They all move, and they each move around a certain point. This one moves around the top left point. This one moves around the center. This one rotates from the bottom right. So this is the transform origin we are talking about. We can also use it in GSAP. So we're going to modify our code. We're going to leave the scale. Let's scale it. We're going to remove the scale on the y-axis. Let's scale it to 1.5. So we're going to enlarge the lungs, and we're going to set a transform origin of top left. We can also express this in percentages. For example, I've prepared this diagram here. Top is 0, and here is also 0. So top left is 0%. Like this, 0%, 0%, 0%, 50% is basically center left. 100% on the Y and 0% on the X is bottom left. Well, you get the idea. We're going to leave it as top left for now so we can see the effect. Let's copy this, paste it into our code editor, and publish the scene. And there you go. As we've expected, the image scales from its top left corner. The default, as you've seen, is the center of the element. So a transform origin of center is the default, or 50-50%. Let's also do top center, or maybe let's do bottom center. Let's see how that looks. So bottom center. Oh, we could do top center with a scale of 0.95. Just a second, so you see what I mean. So it seems like the lungs are just animating, and this stays still. The trachea, I think. There you go. That looks nice. So that's about it for transform origins. We're gonna see more of this in the next chapter. So for our next project, we will talk a bit about rotation. I have set up a new scene, a new slide. On this slide, we have 3 stars, which are in the PNGs. They're the same PNG. Each star has a different accessibility name. The first one is star-1, the second is star-2, and the third is star-3. Now I have also marked some origin points, some transform origin points around which we will attempt to rotate that star. As you can see, I have expressed their value in percentages because I want to showcase that you also can go into the negative with percentages, so you can go outside of the bounds of the star, for example. So here we are, it's like having the star, it's like having a second star here. So minus 50 is basically 50, this is 0, and this is minus 50. So this is 0, and this is 50, as far as transform origin points go. So we will also explore that. So let's start writing the code for each star. I'm going to first create an execute JavaScript trigger, and we will copy the code from the lungs, Ctrl S to save it, then close it, and then we're going to paste it into the star. And I'm going to attempt to rename this Ctrl H, star-1, replace all. Just so I will check if the star, it's with no capital letter. So star-1, I'm just gonna do it manually. Then, so, be careful. In case you have named your variables, for example, lungs or car or whatever, in case you want to name this star-1, this will not be an accepted name because it will assume that you are trying to subtract a value of 1 from a variable defined as star. So if you want to do to name it star-1, just use a hyphen like this, or just write a number like this, so without any hyphen or stuff. I'm just gonna undo this. This was just a quick tip. So instead of scale, we are trying to rotate this star. So I'm gonna type in rotate, and let's do a 360. No, it's not rotate, it's rotation. So a rotation of 360, or a duration of 12 seconds. Let's put it at 12 seconds. No yo-yo, we don't need that. A repeat of -1 is fine. No eases for now. We're just let it default to linear. As for the transform origin point, since this is the first star, 50% 0, we can leave it at, we can express it as top center. We're good. So I'm going to paste the code. Then I'm going to, well, I could duplicate the trigger. Let's do just that. Let's duplicate it here as well so we can have it as a reference. This is star-2. It's basically the same code. The only thing that will differ is the transform origin. So this is the center one, or the 50-50. 50%, 50%, perfect. Just gonna replace the code. And the third one, I'm gonna duplicate, oops, I'm gonna duplicate this again. This is star-3, and this is 50% minus 50%. Let's delete the center. copy this, paste it into our storyline. Okay, now let's publish this scene and see what we have. And there you have it. All the stars move according to our transform origin that we set. Maybe we should have added some eases. Let's add one to each and every one so the movement is a bit more fluid. Let's add this. Linear ease with no eases. Okay, now I'm gonna copy the code again to the storyline editor. *1, *2, *3. Publish it again. There we go. Now it's more smooth. Another thing to keep in mind about rotation is that we can also rotate the elements around their specific axes. So let's try rotating this on X, this on Y, and this on the Z axis. This will be interesting to see. So let's redo the code. I'm gonna copy it and paste it into each of the JavaScript triggers in storyline. And let's see what that gives us. We're gonna publish the rotation. And as you can see, this is very interesting. So rotating on the Z-axis is basically the default. Rotating on the X-axis is basically rotating it around the axis. So it's rotating it in 3D space towards us and away from us. While this one is rotating as around the Y-axis. So it's basically like you would have a coin flipping in the air or something. So keep in mind that you can do very interesting things with rotation, because you can set it to rotate around each of the 3 axes. So you can basically rotate an object in 3D space. Perhaps you saw in our example with the stars that it's pretty hard to move and edit the code for several items at once. You can easily make mistakes. You can forget to copy, forget to paste something. It can quickly turn into a mess when we have several elements we need to animate. So I have created a new scene with a new slide, and we will cover staggers. Now, staggers are a way for GSAP to animate multiple elements in a sequence. Let's go to the documentation a bit and see what it says about staggers. Let's run this example code. So each one has a stagger of 0.2 here, which means that they will run, each animation will run 0.2 seconds after an animation has begun. A stagger value of 0.1 would cause the 0.1 second delay between the start times of each tween. So let's fork this a bit and edit the value to 1. See what that gives us. So it waits a full second between each animation. So this begins, it waits a second, this triggers, and then they all go out in style. So we will just copy this. First off, let's create a new document here in our Visual Studio. Let's name it Stagger.js. We will use the code. We will need this to select our vehicles. As you can see, each vehicle has the accessibility name of vehicle. I'm just gonna double check. This one's vehicle. This one is named vehicle, and this one as well. So we have a red car, a van, a blue van, and a green motorcycle, all with the accessibility names of vehicle. Now we are going to use the document query selector all property, which, as you perhaps you remember from our first lesson, selects all the elements with a name of vehicle in our case. So it selects all the elements regardless of how many we have, all the elements which share a common ID. In our case, the ID is the accessibility text of vehicle. Now, the code we need, we can get straight from the documentation. Let's just paste this into our Visual Studio, add a little comment. We're just gonna copy the animation target here. So what do we want to do? Let's move them on the x-axis, so parallel to the road, by a value of plus equals 50 pixels. So we're going to move them 50 pixels to the right each time we press the button. Copy this, click the button, create an execute JavaScript trigger when the user clicks button forward, copy our code, it's okay, and we're gonna publish the scene and see what kind of effect we have. So I'm gonna press the button, there we go. They all move in a sequence. But why does the motorcycle move first? Why doesn't this car move first? Let's explore for a bit. As you can see in our order here in our timeline, I have the motorbike first, then the van, then the car. If I were to move the car here and the motorbike up, well, you know what? Let's just leave the motorbike here. You will see that the car will move first. So no other changes. I will make no other changes. Just change the order in the timeline. In storyline, publish, and according to my logic, the car will move first. And as you can see, this does happen. Let's increase the stagger time from 0.1 to 1 seconds, just so we can see better. I'm gonna paste this code back into our JavaScript trigger. Car moves, motorcycle moves, van moves because of their order in our timeline. Now this order is based on the Z index. We now have the car, the motorcycle, and the van. So the van has a Z index of 11, the motorcycle has a Z index of 10, and the red car has a Z index of 9. So the Z index is actually representing the position of our elements in 3D space, so on the Z axis, which is an axis that comes from the screen towards us. Now, if we were to arrange all the elements one on top of the other, you will see that they look like this. But when we actually think about it, they have an order on the Z axis depending on their position on the timeline. So this is how it might look like. So if we think about our scene, the background has the lowest Z index because it's right there at the bottom of the timeline. And then starting from the background, we first have the motorcycle, the van, and the car in the timeline. So each one has a greater Z index than the other because of their position in the timeline. So this is what the Z index is. And this is basically what the Stagger uses in order to determine the order in which the animations run. So the car has the smallest Z index because it's closer to the background. So it's further away from the camera, while the motorcycle has 10 and the van has 11 because the van is the closest to our camera. So if we move these around, we get the order, we put them in here. So the timeline in storyline controls the value of the Z index. This is very important to keep in mind when you're working with stagger animations. So the Z-axis adds depth to the scene. We have seen the Z-axis in effect when we rotated these stars in 3D space. Moving on, we are going to talk a bit about GSAP timelines, which are an easier way to animate and control each element of the animation. As you've seen with staggers, there are many things which can influence animation, and we don't have that much control over each individual element. For example, if I wanted the motorcycle to move on the y-axis and only the van and the car to move on the x, we can't do that. Everything must move as one. With timelines, there are no such limitations. For example, in this slide, I have the red car again, but this time it's called car as for the accessibility property. The same goes for the van. The blue van is called van, and the motorbike is called a motorbike in the alternative text. So for starters, that's the main difference. We are also going to move to the code. Also, first, let's check the documentation a bit in order to see exactly what timelines are. So they allow us to have greater control over our animation. This is a nice visualizer of what a timeline is. So each animation plays in sequence and can be easier to control. So for example, look at this. The green moves over a duration, the green box moves over a duration of 2 seconds. This purple box moves over 1 second and 1 second. This is very nice, nicely represented here. We can also have animations triggering at the same time. For example, look at the green and purple box, and then a gap of 1 second, and then the purple box triggers. All of it is explained here, and so on and so forth. So first off, we will go to our Visual Studio, create a new document. I'm going to name it timelines.js. I'm going to copy this part right here. But this time we're going to select the vehicles, and I'm going to specify that we're going to select the car, van, and motorbike. So we're going to use a query selector and say car, animation target. Now we can make a dash like this, or for the purpose of this exercise, let's go to car. Let's name the variable to car, and just gonna duplicate this line. And van, we'll rename this variable to van as well. Then we're gonna copy it again and motorbike. But we could also have used animated element 1, element 2, and element 3, whatever. So we have selected all of the elements on our page and store them into variables. Now, what's the next step? The next step, if we check the documentation, is to create a timeline. We're going to just copy it, a line from here. So a GSAP timeline. I'm going to create a GSAP timeline named TL. This is TL, not T1. Let's just name it my timeline to avoid any confusions. And then we will add tweens to the timeline. Remember, tweens are just the individual animations that we will now add to the timeline for our purposes. But okay, instead of GSAP, we will write my timeline .to, and now we're going to write the rest of the animation. So our target will first be the motorbike, and we're gonna give it an x of plus equals 100 pixels and a duration of, let's make it 3 seconds. So the motorbike will move first, then my timeline.to, let's write the second, or you know what, I'm just gonna duplicate this and replace the important elements. So let's go with the van next. I'm just grabbing the order there in a line. So this will move, let's move this on the, let's give it an x of 100 and the y of plus equals 50 pixels. So it will seem like our van is being abducted by aliens. A duration of 1 second should suffice. And we're gonna also affect the car. And this we're gonna just move it by 50 pixels towards the right. Let's give it an ease back. Let's see what this does. Back in out for a duration of 2 seconds. Let's copy this code. Now we could have also used this for the stars. So we could have had for the stars, for the rotation of the stars, we could have had all of these in one trigger element. You could have selected all 3 stars here and then write all the code in one JavaScript trigger element. But so we can always go back. When we find a new solution, we can always go back to old exercises and refactor them or improve them, if you will. So when the user click, I'm going to execute this JavaScript that I've copied from here. I'm going to publish this scene. There we go. Now if you press the button, the motorcycle will move over 3 seconds. The van will, it's the opposite of being abducted by aliens. The van will try to overtake. If I press again, motorcycle will move. Well, the van leaves the road and the car moves in the turned position. You can already see the level of control we have using timelines. Let's edit the code for a bit. Let's just remove the y value from the van, make it 70. So what if we want the van and the motorbike to start at the same time and the car to go last? Well, we also have the answer for this in the documentation. We can control the start, we can insert gaps. That means that if we insert this here, comma, and a lesser than sign like this, this means that the van will start at the same time. The animation for the van will start at the same time as the one for the motorbike. So that's that, and the car will be the most patient of them all, because it will start after a 1 second delay from the end of the last animation. Let's copy this, move into our storyline, replace this here, publish, and move. There we go. These two move. 1 second passes, the car moves. So you can see these two move at the same time. At the same time, 1 second passes. 1 second from the end of the timeline. So 1 second from the end of the previous animation. Not the previous animation, the timeline. If I wanted to add 1 second after the end of the previous animation, I should have used a greater than sign. I think. So as you can see, there are a lot of ways to experiment with these timelines in GSAP. These are a very, very powerful tool. Oh, and you can also, you don't have to repeat this my timeline at the end of every timeline so this is also a valid syntax, having each of them on one line like this, having some trouble, but you get what I mean. First off, I'm gonna rename the alternate text for the star. I'm just gonna leave it at star, and then I'm gonna insert a slider. Let's do the third one, about this big, I think. I'm gonna center it, center the star as well, and then we are going to check some properties on the slider itself. So I have a variable here. I'm gonna rename it to slider position, and I'm gonna leave it to update when the slider is dragged. So I'm gonna select the second option. As for the start and end positions, how about we make the start somewhere around here? So 280, let's say. 280. The start isn't just gonna move 280, but we're just gonna input some random references, some estimates. 920. Where is it? So 920 for the end. Okay. So we want to move the star in about this interval right here. Now initial, we'll set it to, oh, it's okay at 280. Let's also insert a text box and expose this variable. So slider position equals, we're just gonna have the variable. Oops. Let's center the text. So we're gonna now create an execute JavaScript trigger, and the trigger will execute when the variable of the slider will change. So when slider position changes, this JavaScript code will fire. And slider position, just a reminder, is our slider variable. So we are going to move to our code editor, create a new file, call it slider movement.js. And we're gonna, let's use this code right here. I'm gonna copy it. I'm gonna copy this one from the long section because it has the variable set as animation target. And we're gonna set this to star. Select the star. Good. Now all we have to copy is what we want our function to do. So we need to create a gsap. Oh, it just keeps doing that. Gset. Why does it do that? I don't know. I'm just gonna copy the function straight up from here. Okay. Okay. And the animation target is the target of our animation. Brackets. We're gonna set the, oh, excuse me. I'm gonna use the gsap.set function. So we are gonna set the position on the x-axis to what exactly? Well, we're gonna use the slider position variable. So in order to do that, we need to get the slider position variable from storyline. So we're gonna get the player, and then we are going to get the slider position variable and store it in a JavaScript variable that we're also going to call slider position. Okay, equals player dot get var. That's not it. We need to put it in quotes. So even though I called it here slider position, this is not the same variable as the same variable that's in storyline. So this is the separate JavaScript variable. I could have named it any way I wanted, but I just named it slider position for clarity, I guess. So we're going to set the X to slider position. And that's it. That's all the code we need for this stage. Let's also add a comment. So animate the star. You don't need to comment your code, by the way, but you should to make it easily understandable. Copy this to the JavaScript trigger. And right away we can publish this project and see what we have. So in theory, when I move the slider, the star should move as well. Slider position updates to 280. And I'm gonna move the slider, and as you can see, the star moves as well. So I don't know why the star doesn't move to this point right here, which is basically 920. This is 920 on the x-axis. 922, but you get the idea. And this is 280. So I haven't been able to figure out that mystery. Nevertheless, we can just estimate points our star might move to. I'm just gonna perhaps remove some of the pixels from here, so maybe set it to 260. I'm gonna set the star to 260. And as for the end, let's set it to 720. So when the slider position is 720, the star is here. So let's set it like that and see what we are left with. Double check. I don't know why it keeps changing the tab when I change the variables, but that's storyline for you. So it's closer to what I want. Maybe even 240 will work as the start. Let's change it as well. Where are you? So let's set it to 230. 230. Let's see how that looks. Publish it again. There we go. Now it's perfect. It's just the way I want it. So it's just about approximating the correct value. Now that we have this, I'm gonna save this. Save also here. What else can we do with the star? So what I suggest doing is adding some rotation to the slide in the same between. So we're gonna put a comma here. So rotation is, and I want this rotation variable to also depend on the slider position. For example, if the slider is here, it should be upright. Let's say the star should be upright. And when I move the slider, the star should begin to rotate. So our only movable variable is the slider position, which changes each time I drag the slider head. So what I'm gonna do is let's just comment out a new section and let's create a var slider rotation, which should be equal to slider position. Let's see what that gives us. It's not gonna give. Gonna fill this out here as well. It's not gonna give us a good result, but just so we see what happens. We're gonna need to divide it by, let's just see what happens. So here, it's basically rotated to 30, and it keeps rotating until it reaches 720. This is fine, but I want the star to start out in an upright position. So I'm gonna just keep in mind the length of the slider, and where is it? So I'm gonna have to delete the end to subtract the start value from the end value to get the length of our slider. And then we are going to use that length. We're gonna divide the slider position by its length, and then we're gonna multiply it by 360 degrees. So if we divide it by its length, it will give us a number between 0 and 1. So that will help us move only on the 360 degrees, only in a 360 degree circle as far as rotation goes. So let's try it out. I'm gonna, you know what? Instead of using numbers, so instead of using 720 minus 230 in our code, I think it would be best to have them as variables. So right here, let's just put a section where we declare our variables. So var slider start equals, and it was 230, and var slider end equals 920. I think it was 720. 720. Good. So, okay. Slider position divided by slider and minus slider start. So this will give us the length of the slider. We could also have a new variable for the length. Maybe we should. Let's put a new variable in. So var slider length equals slider end minus slider start. There we go. Now it's a lot easier to read. Slider length. And it's good that we don't have numbers in here because they're much more visible in this part. If we want to change it, we can change them right here. Since they're variables, the change should reflect throughout our code. So just keep that in mind. And we're gonna time this by 360 degrees. Now let's see what that gives us. I'm gonna copy this code, paste it into our trigger, and publish the project. Still doesn't work as intended. So when slider position is 230, let's bring out the calculator. When slider position is 230, the formula goes as like this. We have the slider position, which is 230, divided by slider length, which is our end value, 720 minus 230, our start value, which is 490. So we have a slider rotation of 168.97 degrees. So 169 degrees, let's say, for our starting position. What we're going to do is delete the initial position of the slider. So we're going to delete the slider start so that it starts from a value of 0. Copy the code again, paste it into our JavaScript file, and now it should start from an upright position. There we go. Just as I want it. So you see, getting things right takes a lot of troubleshooting because things can go wrong, maybe with storyline, maybe with your calculations. So a lot of double checking needs to be done in order to ensure that this works. Now, what else can we do with this animation? We can also affect the opacity of the star. So opacity goes from a scale of 0 to 1. So this will also be a calculation that similar to what we've done here. So let's just add the opacity property to the GSAP tween. We're going to create a variable called opacity, slider opacity. So it's a new variable, and we are going to use the same calculation, basically. Add it here, copy the code, see what that gives us. So I'm going to paste it into our trigger, and as you can see, it only affects opacity a little bit here at the start of our animation. Now, why is that? We must have done something wrong. Let's see what. So the first time we run this, we have a slider position, which is 230, minus slider start, which is 230, divided by slider length, which is 490, times 360. So the opacity starts at 0, which means that the object is invisible. So the next few frames, let's say, we are at 232. So 232 is our slider position minus our slider start, which is 230, divided by 490 times 360. And we have an opacity greater than 1. So that won't do, basically. We need to get a number that's within the range of 1. And I just found out what I did wrong. I shouldn't multiply this by 360, so this is where I went wrong. Because we only did that for a rotation. 360 was representing the degrees. So no biggie. I'm just gonna delete the 360 from here, from the opacity line, paste it in the trigger, publish the course. Now it should work as intended. So it goes from 0 to 1. If we wanted to invert the value of the opacity so that it goes from fully visible to 0 opacity, all we need to do is go into the code and subtract the whole formula from 1. Make sure you put parentheses here, copy the code, paste it into our JavaScript trigger, publish, and it has 1 opacity and then slowly fades away. Now you can see this is very powerful stuff. We didn't have to do much coding in the GSAP tween. Well, mostly we had to deal with the hardest part of this was the calculations, basically. But this can also be powerful because you can animate several elements with the same slider. For example, I could duplicate the star and have a star that moves on the vertical axis. Let's actually do that to demonstrate. So I'm just gonna recolor this star to, let's make it blue, fully blue, and give it the accessibility name of star, blue star, like this. In our code, I'm just gonna duplicate this line, animation target 2, and we're gonna set it to blue star. I'm just gonna duplicate this tween, just put animation target 2 in here, and instead of X, I'm gonna put the Y value. Now I'm gonna keep the rotation and opacity the same, copy the code, execute JavaScript, and if we publish this line now, we will see that I move both stars with 1 slider. Now, of course, the blue star is going from 230 on the y-axis to 720, which is off screen. But you can also adjust the position as well. You can create a formula that better suits your needs. Now, we are going to look at some practical examples that I've used in the past in my projects, and that will help you get a greater feel of what you can do with GSAP and how you can apply it to your projects as well. I have created an empty slide here. I'm just gonna, you know what, I'm just gonna leave the triggers here, the next and previous triggers, and we are going to do an animated counter that goes, is kind of similar to the counter of a slot machine, for example. like the ones in Vegas or whatever, when you get the 777 or 3 cherries or whatever. So we're going to do that for one of our infographics. Let's just insert some random text. So let's say 23% of people, line break, say that animations are cool. So we have this 23%. So instead of writing 23% here, I'm just going to center the text, maybe move the percentage here. Let's increase the font like this. And over here, I'm going to put the 23. So let's align it so it seems like it's part of the text. There we go. Let's give it a nice and reddish color. Oh. And we are going to create some shapes to mask, because we need some shapes to mask the text, because we are going to create we're going to type out several numbers which we'll use in our counter. So I'm going to just select a shape, a rectangle, send it to the back, put it on maybe I don't need it on the top. Just going to take this number here, and I'm going to start by saying 22, 21, or let's just go from 99, 98, because all the people think that animations are cool. 95, just gonna decrease the font while I populate the list. So 94, 93, 92, 91, 90, 89, blah, blah, blah. So I'm gonna increase the font again to 88, align this like so, and send it to the back so that it is behind our rectangle shape. Let's also give this a bit more, just blend it in better with the background. Now, we are going to animate this counter. To do that, I am going to go to the accessibility properties, and I'm going to rename this to counter and close. And now I can add the JavaScript. I'm going to execute the JavaScript when the timeline starts on the slide. So click OK, move to our code editor. Let's go and create a new JavaScript document. We're going to name this as, what is this? An animated slot machine. Let's just name it slotmachine.js. And we're going to copy this code from here. So select the counter. I'm going to copy this code from the lungs because it's basically the same. Counter, so that we don't type it out. And copy the animation as well. We don't need all of this. Maybe the duration, we need the duration. And the ease, I'm gonna let the ease as well. So we are going to use the from function because we want it to go from a random value to go to this 99 value, but to this position more like, which we have already set on the y-axis. So we needed to go from a negative value of about, what is it? Where does 89 appear here? So of about minus 1500, let's say, to I think it was 142. So we need to go from y minus 1500 over, let's say, 10 seconds to go from this y to its initial position. Copy this, paste this into our JavaScript trigger, publish this scene, and let's see what we've got. Nothing happens. Why is that? So stuff did happen, but it was very, very slow. I almost took this for an error. So obviously the direction is not okay. How about if we put here 500? I tried this. So I changed the value to 500. Let's see what that gives us. I must have made some mistake in my calculations. Again, we have to wait for a long time, but the number comes from the bottom. Let's change this duration to something like 3 seconds so we see right away if something's wrong. And let's give this a value of 1500, positive 1500. Let's see what happens. It should still come from the bottom. So there we go. I think it's something to do with how we write this value. How about if we write it like this? Maybe the syntax is wrong. There we go. So the syntax was wrong. We had to put it between quote marks, the minus as well. It must have mistaken the minus for a subtraction sign. So let's see it again. I'm going to refresh the page. And again, maybe lower the value to something like 1100. Let's see how that looks. And publish the course. There we go. Now it seems more natural. And look at this cool counter that we did. Now you can also, for example, you can mask it better by blending this shape into the background completely. So if I do it like this, it's completely blended in the background. There you go. You can also put this in a scrolling pane. So I can put the counter, let's name it counter. I can put it in a scrolling pane from here. And then I can put it wherever I want on my slide. But I honestly don't like working with scrolling panes because they are very volatile and unpredictable to work with. So this is our counter. We can also do other things to it, set its opacity, set its scale. It depends on what we want to, what is the effect we want to achieve. So in this project, I have created a long timeline of major breakthroughs in cardiac studies, and we are going to animate this timeline using a slider like we did in this example right here. So I'm just gonna create a slider. Let's just put it somewhere around here. I'm going to go and I'm gonna leave it as a slider 3. I'm gonna copy this entire trigger from here to here. I'm going to create a new JavaScript file, heart slider, heart timeline.js, and I'm going to edit this code so that I'm left only with the bits I need. So I'm going to select the heart, or just a second, the heart is this element here, so the image of the heart, and I have grouped the entire timeline as one single group, including the heart, and I will give this the accessibility name of heart timeline. So I am going to select the heart and name the variable heart, and I'm going to also select the heart timeline, which I will call heart TL. No, let's just call it heart timeline. Okay, and we have here heart timeline. Perfect. Now we are going to keep this section where we declare the slider start and slider end, just in case we need to alter the position or you know what? Let's just select everything and Control / so we can comment out the values. Maybe we don't need them after all. We're going to delete this rotation and opacity slider. Here I'm going to animate the heart timeline. We are going to set the heart timeline variable we got here, and set its position based on the slider position. Let's just write down the initial position of the slider. So let's start it from 200 with an end of, let's say, 4000, because this line has a length of 6000 pixels. So let's just give it this value. We're gonna approximate anyway. I'm going to also change them in here so we know the values. Let's copy the code and we're gonna execute this JavaScript when our variable slider3, let's actually rename it so that we know, heart timeline slider position. It's okay if it's a longer name, as long as we know what it defines. I'm gonna copy the name of the variable and change it here. So we are getting the slider position, but this time we are getting the variable heart time slider position. So heart timeline slider position, we are getting it. And this is our slider position we are using in our GSAP animation. Let me just refresh this. And I'm gonna publish this section. We're gonna move to our timeline. And if we're gonna need to invert this timeline, we're gonna need to invert this formula. So it's gonna be 1 minus slider position, because we are now moving in not in the direction that we want. So let's just do that. Let's just do the calculation here. Slider position equals 1 minus slider position. We can also create a new variable. Let's just do that. So inverted slider position equals 1 minus slider position, and this x will be inverted slider position, just for clarity. I'm gonna copy the code, paste it into our trigger and publish, and let's see what we get. So it's a bit off on the start here. If we scrub this along, we finally get to the end of the timeline. So the end is perfect at 4000. Now we need to decrease, let's see. We need to increase this value here at the start. So perhaps if we bring it to, let's say 600, let's see how that looks. So 600 here. We don't need to copy and paste our code since we didn't quite change it, but we're gonna do it anyway. Publish again. Let's see. Nope. I needed to make it lesser amount here. Let's try 50. Let's try 50. I'm gonna publish it directly. So what about 50? Do you like 50? We're getting there. Maybe if we set it to 0, let's try 0, although I think that might not work. Let's see. Oh, what do you know? It's 0. 0 works. Can we set a negative value in here? So it starts from minus 50. Can we do that? It's so annoying how it... So initial minus 50. Let's publish it so we can just see what we have. This is perfect. And we go to the very end. Perfect. So the final value is minus 50 for the start and 4000 for the end. Great. Now we have a scrollable timeline that goes horizontally. It moves horizontally. This is not something you can do with scrolling panes in Storyline. You can do this with motion paths, but if I, for example, want to switch 1951 with 1929 or make any edits to the timeline, I would have to Or perhaps I want to add in a new element and add it to the group. Motion paths would not allow me to do that. I would have to redo the motion paths. It will just be a pain. So this is a much simpler version of doing this. Now I want to see if we can animate the heart so that it simulates a heartbeat, while we are also keeping the slider interaction. So since we already have our heart in this variable, I'm going to comment here and say we're gonna animate heart to simulate a heartbeat. So how are we gonna do that? Well, we need to place several animations in a sequence. In order to do that, we will create a timeline, a gsap.timeline, and we're gonna chain our animations. First off, let's create a tween in which we animate the heart and we scale it. Let's affect its scale. Let's say 1.05, so a small increase in scale. Let's give it an ease of back. No, let's do power 1 and a duration of 0.2. This should be a very small animation. And then we can also put it right here. We don't need to add timeline at the beginning. Then the next animation that plays will be a decrease in size. So we're gonna change this to 0.95. I'm gonna leave the same ease. This will take 1 second. We are going to also add a repeat of -1 and the yo-yo of true. Now you can see how I added these parameters. You can add them like this to the timeline and all will be okay, nothing will change. Let's copy the code, publish it, and we broke our code. Why? Maybe this doesn't work after all. Let's try without these parameters. Let's see if it works like this. No, this is not gonna work because it fires every time the slider moves. We need to put this in another trigger. So I'm gonna create a JavaScript trigger when the timeline starts. And let's separate these lines of code, create a new section right here. I'm going to get the heart animation only, repeat -1, yo-yo, true. Let's add this to the trigger. Let's add the new code back into this trigger and we are going to publish and perhaps now it will work. Let's see. So the heart keeps beating forever. We're moving it. It moves with our timeline. It still keeps on beating. We have exactly the result we hoped for. You can see we chain our animations. It's actually perfect. It's amazing. So we have the beating heart while the timeline plays. So as a reminder, the heart, all of the timeline is in a group. The group has the accessibility name of heart timeline. Inside this group, we have our heart, which is here inside another group. So picture 1 is our heart, which has the accessibility name of heart. And if we animate the heart in a separate trigger that runs when the timeline starts, and we animate the timeline as a the whole timeline group with the slider, as we've seen in the example with our stars here, we get this effect, which gives us a pretty nice timeline to go through at our own pace. We can explore it as we want. And we have this cool animation at the beginning. This can really add some flavor to your slides. So in this one, we will attempt to do a card flip animation. Now I'm gonna create a new slide. So what is a card flip animation? This is something that basically most of my clients request. I've had this request many times, and there is no way to do it in Storyline. You could, for example, use the swivel animation, but the swivel animation, let's preview it a bit. It does all of these rotations that are unnecessary. It does too many rotations. 1, 2, 3. 3 rotations. And it's annoying to flip a card like that. The effect I'm looking for to recreate is more like this one. I can just press and the card flips to its back, then its front, then its back. I can keep pressing on the card and it keeps flipping away. So no unnecessary extra rotations, just the card flipping back and forth. So we're going to use GSAP to achieve this effect. First of all, let's create some cards. I will create the front of the card and the back of the card. Let's create something cool like this. Maybe with a bit of a shadow effect. Let's add some images. I'm gonna add the image of the astronaut we used. Let's rename the slide to card flip. And I'm gonna paste the astronaut inside it. That should do it. Maybe put a star as well. Maybe it's a Soviet astronaut or something. Put the star in the back like this and have the astronaut in front of it. Let's change the color to something more in tone with what we're looking for here. How about this? This looks nice. And now we're gonna create the back of the card, and I'm gonna insert some text in it. Some lorem ipsum, because I don't have any idea of what to say. Let's make it black, and I'm just gonna delete this part right here. Arrange it a bit. Maybe just keep it to one paragraph. And let's place some decorative rectangles of the same color as our front here. So we're gonna group this as our back and this as our front. And we are going to front, we're gonna name it front, and this we're gonna name back. And we're also gonna give them an accessibility name. So I'm gonna give the group an accessibility name of card underscore front. And for the back, I'm gonna give it card underscore back. There we go. Let's get to the, first let's create the triggers. Gonna execute the JavaScript when the user clicks front, and one when the user clicks the back card. So as you might have noticed, we aren't going to actually flip the card itself on an axis. We're going to do this like a magician does. So we're going to actually do 2 animations. We're going to do one for the front, which we will rotate from 0 to 90 degrees. Then we're going to do one for the back, which will start at 90 degrees. So it will be invisible for us. It will be invisible to us, and then it will flip to, it will do basically a 90-degree rotation, and it will flip to 0. So this is actually what it will look like. There we go. I have left it to 95 degrees just so we can see the blue card. but we shouldn't see the cards. In fact, we should end up with an animation just like this one right here. There we go. So this will be our, this is basically what we're going to be doing. As you see, they are kind of, it's like it's like having a revolving door type of animation, which will give the illusion that the card is rotating. But this is just a revolving door in a cross pattern. Let's go to the code editor and create a new file, cardflip.js. Now let's take from the lungs. This is the easiest to take from. I'm gonna take this first line where we select the card front and card back. So here we got card front for the accessibility name, and here we've got card back. So we've selected the cards. Now we need to create a GSAP timeline. So I'm gonna create a timeline, call it my timeline. No, card front timeline. There we go. So it's specific. This timeline we will be using to rotate only the front of the card. So it's a GSAP timeline. And let's create our tweens. So card front timeline dot set. We will set the back of the card, so card back. We will set it to a rotation on the y-axis of minus 90 degrees. So I'm going to use the rotate y parameter and set it to minus 90. Then I'm going to create a tween, which will affect the card front. And this we will use to rotate on the y-axis. Oops, I forgot my brackets here. So rotate on the y to minus 90 degrees for a duration of 0.5 should do it. Let's see what we have so far. So when the user clicks the front of the card, I'm going to publish this. So when I click, this card should rotate immediately to minus 90, so it should be invisible. And this one should rotate over 0.5 seconds to the right. Let's see. I did something wrong. Can you guess what? It's really easy. I added the alternate text only to the rectangle, not to the entire group. So I'll need to fix that. I have to remove the accessibility text from the rectangle. This happens. You should be careful with this thing, but you know, it can happen. Let's publish again and see it more clearly. There we go. As we planned. Now all we need to do is to rotate the back of the card so it shows again. So we will copy this tween and make it so that it only affects the back. Oops, card back. And it should rotate back to 0 since we already set it here to minus 90. So back to 0. Now the animation should be complete. I'm going to go to our file, paste it in the JavaScript trigger. So now all we need to do is to send this group to the back and overlay this on top, align it so that it's perfectly centered. Now, if we publish this, you will see that we have a perfect card flip. There you go. It rotates around the y-axis. It's very natural. It does it once, not 3 times like the swivel movement. And we will make it so that when you click on this side, it rotates again to show the front of the card. Now, in order to do that, we will just copy this code here, but invert the values. So let me add a comment here real quick. So this is for the front of the card, and this will be for the back of the card. And I will also be naming this variable card back timeline. So here as well, card back timeline and all 3 occurrences. So we also need to change these. So card front here instead of card back. Here we will set it to card back. So we are doing the same thing, but in reverse. Here I'm gonna rotate it to 90, 90 here as well. Copy the code and paste it into the other JavaScript trigger we've left empty so far. Publish. And now we will have a rotating card. Let's see. Bam. Bam. Look at how smooth this is. Of course, we can make it, we can customize it as we desire. We can even, let me select both of them. If we rotate it like this, oh, this ruins my my alignment. Let's see if perhaps this works. If I rotate it by 45, this ruins the alignment of the star. Well, anyway, I'm gonna demonstrate it even if it ruins the alignment. I just wanted to show you what happens. Oh, what happens if I click it now. So it rotates along the y-axis. I don't need to do anything extra. In whichever direction I rotate it, it's gonna rotate around its y-axis. There we go. I'm gonna just Control Z here. Now, what else can we do with this? We can still, for example, animate the astronaut, which we have here with the astronaut accessibility name. Let's just copy the code from here, paste it as a trigger. Now remember, this trigger works when the timeline starts. And I'm gonna also paste the rotation of the middle star, which rotates around its central point. So I think this is the middle star. This is for star 2. And here our star has, let's set it to star 2. So copy the trigger, paste it here, publish. Now we should have the astronaut floating and the star rotating. Let's see. The star rotates around its center point because that's the last thing we did. We shouldn't have that. We should only have rotation without Y. Publish it again. So if we view the project now, we have a nicely animated front. If we rotate, we see the text. And if we rotate again, the animation continues. And this is really cool. And as you've seen, there is no complicated setup required. It just works out of the box, so to speak. And it's way better, in my opinion, than anything offered by Storyline by default. And I'm using it in my projects to create card flip animations whenever clients insist upon adding them. There we go. I'm going to show you something that honestly blew my mind when I first found out that it is possible in Storyline. I'm going to create a counter that animates automatically. So the disadvantage of this method is that we can only input manually a few numbers until it gets really, really boring or really clumsy to do so. So what if I want to animate a number, for example, that goes from 500 to 1500? Well, that's just gonna, if I were to do it like this, can you imagine the amount of numbers I would have to write? So there's an easier way of doing this. First off, I have to create a new variable, a new number variable. I'm going to call it my number. Really basic. I'm going to give it a value of 500. And here I'm going to just replace this with my number, with a reference to my number. Let's say here some random text. And now let's see how we can animate it. I am going to copy the button from here. I'm just going to copy the fade button because I don't want to create a new button. Just going to change the text to increase the number or pump it up. Just going to delete this code right here, leave it on blank, and move to our Visual Studio document, create a new document called, how should we call this? Let's call it animatedcounter.js. So what do we need to do now? Well, we will have to get the player. So player equals get player, and we will now get the my number variable. And put it in a my number variable in JavaScript. So player.get var my number, semicolon. Now that we get the my number variable, we are going to use GSAP to animate its value. So we don't need to, as opposed to the other animations, we don't need to select the element because this is an internal variable of storyline. This isn't an animated, this isn't a rectangle or a shape path that we can select. This is just an internal variable. We are going to simply use GSAP to change that variable. So I'm going to write GSAP dot, whoops. So gsap.to, and in this to function, I will use the smart object property of GSAP, which will allow me to animate the value of my number. So this is the target of our animation. And now I'm gonna put a comma and go on another line and put the parameters in. For example, the duration, let's animate it over 10 seconds. Now we're gonna input the value we need it to go to. So we said that it should go from 500 to 1500. Let's give it an ease. Let's make it linear, simplest ease. And now we are going to run an onUpdate event on a function. This is a GSAP property that is designed for updating numeric properties. So our variable here, which is a number, an integer. It's used to perform actions, update values during the animation. Now, what is the onUpdate function? It's a function that GSAP calls on every frame of the animation and allows us to perform certain actions while the gsap.to function is running. So we will use this onUpdate to update the my number variable, which is an integer variable, to update it while the function is running. We're just gonna input the my number. So we are now inside the brackets for the onUpdate function. So my number equals, And I am going to use a math.round, and this will target targets square brackets 0 dot value. Now this is basically an array. This gets the current value being animated. If the value is a float, so a float is a number separated by commas, so 1.55, it rounds it to the nearest integer, which is 2, which should be 2. So this is what we're doing here. Let's put a semicolon in, and let's also add a console log with my number so we can see in the console how this works. And also here we will input the player.setVar function, which will set our number so that it updates it in real time. So my number, the storyline variable, and we will set it to my number, the JavaScript variable. And let's also add a now onComplete event. So when the function completes, this will run. I'm sorry, I had to put the comma in after the parentheses for the onUpdate function. So put the comma in, and now let's put the onComplete function. So this will run when the animation completes. Let's just give it a console.log animation complete, just so we know that the animation has successfully been completed. Now I'm going to close all these brackets. So the brackets for the function will be closed, the bracket for the initial definition of our parameters, and the bracket for the round bracket for the gsap.to function. Copy all of it, paste it into our JavaScript. And now if we publish this document, let's see what happens. I hope I wrote everything correctly. Let's see. So in theory, if I press this number, this counter should update in real time. If I press this button. And it does. Look at this. It goes all the way up to 1500 over a duration of 10 seconds. Now let's right click somewhere on our document and go to the Inspect tab and access our console. And as you can see here, we have every number that this function goes through because we called a console log function in our onUpdate. So we have every number starting from 500 to all the way to 1500. I'm gonna scroll. And at the end we have animation complete, which is what we told it to do when the function was completed. Now, this opens up so many possibilities with counters. Let's refresh it, see it again. It's absolutely beautiful. There we go. It just updates in real time. Perhaps if I entered let's try changing this initial value from 500 to 900. So that's the only change I need to make. If I publish, this will go to 1500, no problem. It's going to take 10 seconds to get it to that number. And on complete, we can run another GSAP function, or you can see how many possibilities this opens up. I was so blown away when I found this. Now, another nice thing about this is I can divide here by 50 and multiply by 50. And this will increment our text in increments of 50. So this will increase our number each time by 50 rather than by 1. So 950, then 1000, then 1050. Let's publish it and see if it works. So as you can see, you can change the formula inside the onUpdate function, and it will, there we go. So in case we don't want the counter to run like this, one by one, we can just increment it by 50 if we change the formula. Now, another thing you can do is create an image carousel. I have here some images which I arranged in a group. Now, these are some random images. Let's see them. These are some random images, and here I will do basically the same movement, but I won't use a slider. I will just use buttons. So I'm just going to copy this button here and make it, rename it to back. And this one I'll rename to forward. And now we will use these buttons to control this animation. Make sure to select the group. I'm just gonna right click it from here and group _1. That should do it. Let me just create a new document here and image carousel.js. And I'm going to use the code right here to select group _1. And now, depending on which button is clicked, I will copy the code in each of their triggers. So let's rename this to button back and this to button forward, so we know which trigger corresponds to which button. So if button back is pressed, we can also do this code in one single trigger, and when the button is pressed, for example, change a variable which triggers this code. You have so many options. I have chosen for this one to put the code in separate triggers. So if the back button is pressed, I will have a gsap.to function, which will target the animation target with the following parameters. So duration of 2 seconds. So over 2 seconds, move it by, and you know what? We're not going to use pixels. We're going to use the viewport width to move this. So move it by 3 viewport width. So VW. So move it by minus equals to viewport height, 3 viewport width. And if the button forward is pressed, move it by plus 3 viewport width. Let's copy this into the script for the back button. And let's copy first this and then this into the script for the forward button. And if we publish it right now, we can see that if I press forward, the entire carousel moves by 3 viewport width, which apparently it's not that much, so we need to adjust it. But there you go, it happens. It's rather smooth. Let's adjust the numbers. So let's move it by 15 on each button press. So for button forward, I'm gonna move it to this trigger, and I'm gonna copy it for button back as well. That should work. Let's see. There you go. Now it moves a bit more. This is what we wanted. You can also set some limits here. For example, only run this if this number is larger than whatever or smaller than whatever. So you can do a lot of things with if statements to limit the range of movement for this carousel. I just wanted to showcase that we can also do this type of animation, not only using sliders, but just simply by using buttons. And it will have the same effect. We can move it on the x-axis, we can move it on the vertical axis. So yeah. Now we are going to cover one of the problems with GSAP animation, especially affecting position, animation, and rotations. In order to demonstrate the problem, I will just draw a rectangle shape here and another here. Now, this is because on resizing the window after export, these elements will move, will not keep their position. So this makes GSAP animation harder to do for precision animations. So let me first just publish the entire project, and let's see what this is all about. To get an idea of what are the values that are affected by a window resize, let's actually go to the elements pane. I have right click on inspect, and I have now located the car in the elements pane of the page. I'm gonna resize this, and look at that. You've seen a bunch of blue lines, and they affect the there you go. They affect the transform origin of the element, the transform, the rotation. They affect the rotation. They affect the transform translate, and they affect the width and the height. So each time you resize, these elements are affected. So I have published the entire project, and you can see that if I move back and forward, the rectangle shapes I've drawn will help us figure out what position our elements are into. Let me just resize, and boom, you see, even if we used viewport height as a unit of measure for our position, it still doesn't work. It still moves a bit on the y-axis. If I resize the window, if I maximize it again, the problem goes away. This can also be seen in the red car animation we start at the start. Look, if I resized, the position changes. If I resize the window like this, I get all sorts of jumbled effects. Here for our astronaut as well. If we resize the window, look at this. It just keeps going all over the place. The ghost, however, does not do this. So this is only for animations which involve positioning or rotation. Let's see the lungs. The lungs are affected as well because I have selected a fixed point for them to scale around. I think for animations which scale from the center, this doesn't happen. Let's see the heart animation. So I'm gonna move it again. And as you can see, since it scales from the center, nothing happens with it. And you can also see that timeline doesn't change here, even though I think it has a slight movement on the y-axis, but not that noticeable. So this animation works well. Let's go to the rotation animations. As you can see, these are all jumbled up as well. The traffic jam, these are all jumbled up if I move them. The timeline traffic jam as well, because they use positions. These one as well. I think since we're animating the position, there we go. So something is going wrong here as well. The counter as well, we use position in it for its animation. I resize the window. The card flip as well, since it flips around the y-axis, which is fixed. If I move it or anything, I will risk breaking my animation, changing its position. The counter doesn't, because of course it doesn't animate the position, it just animates the variable. So this is safe from any resizing issues. And the image carousel we already covered. So that's a huge problem if you want to use positioning-based animations. Some people suggest that solutions involving viewport height or viewport width, so using these values, might keep you safe, but they don't, as you've seen. There's also a window on resize function in JavaScript, which should work, but I haven't gotten it to actually work in Storyline. But this should, I don't know, do something when you resize the browser window. It should detect the resize and it should refresh the page, so to say. So in lack of any solution of this type, I figured out something that might help you. Here's a list of things that you should keep in mind when using position animations in GSAP so that you don't risk breaking your animation or your slide layout. Well, first of all, you can suggest via text prompt to your learners to just use the full screen version of the course, enable the full screen button here in the player, click OK, and if I publish it and move it to full screen, I will just enter full screen. If I move the car, I move here throughout my project, nothing will happen since I'm not risking resizing my window. Another way would be to ask your users to not resize the window, but that would depend on each user's willingness to do so. Another tip I have is to, and this has solved it for me, whenever you get a movement on one axis only, so for example here we're only moving on the x-axis, I usually create another JavaScript trigger which will run a code fixing the position of this element on the y-axis. So I will use the same accessibility animation target. Let's just write a comment so we know what we're doing. So this is the code for fixing the element in place on the y-axis. I'm just gonna paste this line here because I wanted to affect the group of images. And then if we don't need this, I'm just gonna copy this code, this GSAP code, to lock this element in our position. Let's set a random position. We'll need to adjust this later anyway. So on the Y, let's set it to 80. On the Y-axis, where is it? So Y, 80 pixels, comma. Just gonna copy this code, and I will create a new trigger which will execute the JavaScript when now this is very important, when the variable changes. Where is it? And as for the variable, we will select a built-in variable which changes on every frame or on every second. And this is project's elapsed time. So this will count the time which has passed since we started viewing our project. And by its nature, this variable will change every second. And this means our JavaScript will be executed every second. And what will our JavaScript do? It will lock this element in place on the y-axis to a position of y equals 80 pixels. Now let's publish this. Let's publish only this scene so we can see if this works. So we have this image carousel. It's currently locked at 80 pixels. And if I move it forward, it keeps its position. Let's move it back a bit. Maybe I should lock it to a viewport height. This worked when the movement was in pixels. Maybe I should lock it to a value of 30 viewport height, so VH. And I'm gonna put this in quotes since this is the correct syntax. Let's see this. And this is embarrassing. This used to work when I tested it. So I locked it to, let's reduce the value. This is way too much. Let's put it at 10 viewport height, and then we're gonna test it. So this is at 10 viewport height. I'm running the animation for a bit, resizing, and it works. So it works if I'm using the same value. So for example, if I'm doing the movement here, when I press the button, if I'm doing the movement using viewport width, I'm also going to be doing the movement here, the locking in place. I'm going to be doing it with viewport height. Another example, let me just copy and paste the car slide, the slide we used at the beginning to move the car. Let me just edit out the JavaScript and remove the scale element because I don't want to scale the car. And here we use the X value. Let's make the duration 5 seconds as well. Here we use the X value to move the car by plus 100 pixels on the X-axis whenever we push the button. So let's publish the slide again to see how our animation works. So if I press the move car button, the car will move. But if I resize, the animation will break. Let me also just remove the elastic ease. So it's as simple as possible. Now I will duplicate this and run it when the variable changes. Which variable? I'm going to select the elapsed time variable. So this will run now every second. I'm going to use the set. Maybe that's what I did wrong. I'm going to use the set animation target, and I'm going to set it to a Y value of, let's see, approximately 350. Let's say 350. So 350 pixels. I'm going to publish. So this sets the car's position to 350 and it runs every frame. But this also means that the car will be... No, it doesn't work. Who knows why? Did I do something wrong here? How about if we set it to Y% here? Y%, set it to 5. Publish this. So this works. This works. Setting it in percentage, using a percentage works. Well, now I'm just even more confused. But as you can see, I think this is the definitive solution. You should set it in percentages. Let's make it 40% on the Y. Here I'm using pixels. Let's publish and see. So I'm going to press the button a lot of times. Just going to press it, and then resize. And this works. So I'm anchoring the car's position on the Y-axis every frame by running a code which keeps it at a Y% of 40. Let's do 500, see how that looks. Remember, Y% goes to... Oh, this is perfect because it follows the line. We can see that there is no movement, absolutely no movement, because it uses a percentage-based... it uses a percentage to calculate its position. And remember, the percentages it uses, it's based on the actual height of the car itself. So the box of this box right here. So that's why I'm doing 500% and it moves it only here. So it's not based on the percentage of the height of the screen height. That's viewport width, viewport height. So it's not based on the percentage of the, or on the height of the Y-axis. Let's just move it to, what is this, 4 times its size. And this should give us, this should put the car on the road. So this puts the car on the road. And now when we move it, the car remains firmly anchored to the road. And we can also set its initial position at the start of the timeline. So set its initial position to... Actually, let's see what happens when I don't run this code and I run it. So if I affect the movement of the animation target only in percent. So I'm going to move it by 5% plus equals 5 when the button is pressed. Let's see that. So remember, I have disabled the locking in place. So this moves the car. I'm going to press the button a few more times. No, you see? So this is not working. The animation goes back to jumbling up when the page is resized. So that's about it. For this one, we're gonna also, for the image carousel, let's also set the Y% to 5. Let's see how that looks. You can see it's this GSAP, it's a whole lot of experimenting, but when you actually get it right, oh boy, does it work. So here we can see we solved the problem, although I have placed it a bit too high. Let's place it at 30, I think, so we can see it better. There we go. Now it's too low. We have a Goldilocks situation going on here. Let's put it at 15 or maybe 17. Let's just do a random value pulled out of a hat. Voila. Now it works perfectly. And if I resize, it keeps its position. We can apply this principle to all of our other animations that don't work. All we need to do is lock them in place on the axis which we are not using for animation. So if we lock them in place on one axis, we eliminate this problem which occurs when we are resizing the window. But as I said, one simple fix would be to request your users to just view the training in full screen. I think every storyline user at some point wants to create something with an element of randomness in it. So this is my take on it. I'm going to create a wheel of fortune. I'm going to rotate this to a random value and then for the results. Well, first off, I have created a slide with these elements, a background, the wheel itself, and a red triangle that will show us the point to which the wheel has rotated. Now I'm also going to create I'm going to copy this button from here. I'm going to copy this button here. Let me bring it to the front. Perhaps I'm going to put this here. Let's move the wheel a bit. I'm going to ungroup this for a bit. And I'm going to move all of these elements to the left. Group them, lock the background, and I'm going to give the wheel an accessibility name of Wheel of Fortune, written like that. This type, trivia time. So this way of writing a name is called writing in camel case, because in a camel's back we have an uppercase letter here and another here. So the O and the F are uppercase letters. So we're gonna pin the wheel. That's gonna be the text from our button. Let's delete the JavaScript from here since we are gonna write it in the code editor anyway. And we'll rename the button to button spin. Now let's move to Visual Studio. And I'm gonna create a new file, Wheel of Fortune, JS, bam. And we're gonna copy from the latest, which is the image carousel. Just gonna add this Wheel of Fortune text we defined as the accessibility text. And so I'm gonna write gsap.to. Target will be our animation target, and we will animate the rotation to, well, we're gonna put a random value here, but for now let's just put 270 and a duration of 5 seconds, let's say. Perhaps that's too much. 3 seconds should be enough. Just gonna copy this, make sure it works. Just gonna push this, and it works. This is gonna set the duration, the rotation of the wheel to 270. So we're gonna have to go into the code and have the rotation be plus equals 270. So each time the wheel rotates, it will add 270 degrees. Let's replace the code here and publish. And now we have a wheel that keeps on spinning when we hit the button. That's what we wanted. Now the next step is for us to make sure that the wheel spins at the random value between, let's say, 0 and 360 for now. So how are we going to do that? Well, we are going to use the math.random function in JavaScript, which I have explained here in the Mozilla documentation. So this math.random function gives us a number between 0 and 1, so a floating point number. So to get a random number between 0 and 360, we're going to have to basically implement this function here, which gives us a math random between 0 and 1. We're going to multiply it with a maximum number, so the maximum value we want, the top end of our interval, and we're going to floor that value, which means we're going to bring it down to the nearest integer value, and only then we will have our random number. For example, here if I run this, you will see that it gets a random number between 0 and 3 each time I run this. So for example, if I enter here 360, it's gonna get a number between 0 and 360 each time I run the number. Let's actually copy this. So I'm gonna copy this and paste it right into my code right here. Let's comment this. Great. So we have this function that's ready for us to input a max in it. So we're now gonna declare a few variables. We need to declare the maximum we need. So I'm gonna comment this. So I'm gonna put in var maximum rotation equals, and we're gonna set it to 360 for now. Let's try that. And then we are gonna actually, so this is where we declare the function. And this is where we use the function. So we're gonna write it like this, get random int. We're gonna input our maximum rotation here. Oops, maximum rotation, so this one. And we're gonna store this into a var random rotation. And then we're gonna use this random rotation right here. So I'm gonna create a storyline variable in order to expose our rotation. So let's create a wheel of fortune rotation variable right here. Set it to number, and we're gonna just insert a text box and also insert a reference to this variable right here. Let's just call it rotation amount, increase the font size, center it, and put it here so we have it visible. And I'm gonna copy its name. In fact, first I'm gonna go to the code editor, go here to the animated counter, select these two so I don't write them again. So we're gonna get the, let's go into storyline and actually copy the name right from here so we don't make any spelling mistakes. So we're gonna get the wheel of fortune rotation, and we're gonna set it to a variable called SL rotation. So it's SL, so we know it's the value from storyline. And right here after the random rotation is right here after we get the random rotation number, we're gonna just player set var, and we're gonna set our wheel of fortune rotation. So I'm gonna copy it from here. We're gonna set it to random rotation. So here we set this. You might be wondering why I put this plus equal sign between quotes in here. Let me just show you, because if I just put the random rotation number here, let's copy this code here. So the wheel spins, but it spins forwards and backwards because our random rotation is being set right here to the rotation. So our rotation is always being set to the random rotation. So if our rotation is 106, for example, let's Okay, now it's 330. Now it's a lesser amount than 303. It's 203. So it's gonna rotate back to this point. Now, if we move it, it's a greater number than 203. And now it's a lesser amount, so it will move backwards. So perhaps we like this. If we like this, perhaps we can increase this value right here, this maximum. So the wheel always does greater rotations. Let's also exemplify this. I'm gonna publish it again. And now, as you can see, the wheel spins between 0 and 2 times. So it can spin a small amount, or if the random number is greater, it can spin for a larger amount. That's nice. But what if we don't want our wheel to spin backwards? What if we want it to always go forwards? Now, we can do this as well. I'm gonna leave this to 720. So before, with our numeric values, we did this. We put some quotes around it and wrote plus equals. So if I just copy the code right now and publish, you will see that if I press the button, the number updates, but the animation doesn't play, which means that there must be some kind of problem which prevents our animation from triggering. And there is. The problem is that this variable is now a string here. It's not a variable at all. So our rotation doesn't know what number to assign its rotation parameter. So we can get around this quickly by just putting the plus equals between quotes and just adding the plus equals to our random rotation, which will create a string, adding these two together. So if we copy it now, paste it back into our execute JavaScript trigger and publish, you can see that it works as we intended. So no matter how much I click this button, the wheel will only spin forwards because I am adding the rotation to its existing rotation value. So this is it, folks. This is how we can create a spinning wheel in Storyline. As you can see, we have many different options to customize this wheel. I chose to make it spin forward, and its value is always added to the current rotation it's having. And to be honest, it was just a few lines of code. The most difficult part was getting this function right, which we copied anyways from our Mozilla documentation, and then just making sure that the rotation is expressed correctly here. And that's about it. In the end, we have a nice spinning wheel which we can use for our learners to add a bit of randomness to our course. So here's an interesting project we're gonna do. We're gonna create a boom boom device. So this is the boom boom device right here. I've added to the slide a few paragraphs of text, just so it seems like a real slide from a real project we might be doing. We're gonna copy this spin the wheel button from here so we can have a button to activate the boom boom device. So what is the boom boom device gonna be? So when creating the animated counter, which animates the value of a myNumber variable, I also figured out and forgot to mention that the value can also go, so it can go upwards, but it can also go down to a variable such as 0. So we're going to make a counter here, a countdown. And when the countdown completes, we're going to make something happen on our slide. So let's first just prepare the slide a bit. So I'm going to add here a rectangle and create a sort of housing for the counter. There we go. And let's put some text in here. This will be our numeric value. So let's put 1100, center our text. So increase its size and also increase its tracking for a bit. So let's get more tracking here. Perfect. Now it looks like a counter. And the only thing left for us to do is to choose a nice red to go with our feeling of impending doom. Maybe just center it a bit more. Perfect. So we're going to create a new variable. We're going to call the boom timer. So, and set its number to 1100. And then just reference it here in our boom timer. So I'm going to also create a glass, so a window behind the boom device. Now I'm going to name this to window. So I'm going to give this rectangle an accessibility name of window. And let's just create a sort of shape that looks like it could be a window. And we're going to send it to the back. And this is the window that will break when the boom timer finishes its countdown. So now let's just move to our JavaScript editor. I'm just going to create a boom device JavaScript file. So boom-device.js, hit enter. And the first thing I'm going to do is go to our animated counter here and copy all of this. And I have copied the code from our animated counter. This time we're going to be getting the variable called, I forgot how we named it, so boom timer. We're going to get the boom timer, which is currently set at 1100. And we're going to make it over 5 seconds, let's say. We're going to make it go to 0. We don't need to increment it in amounts of 50. We're not going to log it since it's going to flood our console. We're going to leave the animation complete message. We're going to set the var boom timer here. We're going to set it to the my number variable, which is going to be updated here in this function. Just like we discussed in the animated counter video, we're gonna just paste this in here, and we're gonna see if it works. But first, we're gonna rename the button to boom, and just gonna write the prompt as boom. And now we can publish it. Now, if we click the button, the counter goes down really fast, boom. So it would be interesting for us to have now what we can do is actually animate the window so it breaks, quote unquote, when the timer here reaches 0. So how are we going to do that? Well, if you remember, I have given this piece before duplicating and creating the window, I have given it a alternate text of window, which now, since I've duplicated the first rectangle, all the elements in the window have. So all of these blue squares are window in the accessibility pane. So we're going to use that and create a stagger animation, which will animate all of them. So let's first write here the GSAP stagger animation. So we're going to write gsap.to. And we're gonna animate the, well, we first have to get the animation target. So we're gonna just get it right here. I'm just gonna call it window. Let's call it window panes, just so we know what we're talking about. Window here in the accessibility text. So we're gonna animate all the window panes since we're having a stagger animation. We're going to animate them to, now, what property should we animate? Perhaps let's animate their position. We're going to animate their X position. Let's set it to -100. It's actually animated in percentages. Y, so Y% of minus 200, why not? And a Y%, so an X% of -200 and a Y% of minus, or let's make it just 1000 here. We're going to leave it as the default duration of 0.5 seconds, and we're going to give a stagger of 0.2 seconds to each one. So let's see how that looks. We're just going to do this at first. We're going to copy the code like this, see how it works. So it doesn't work, only the, let me refresh this, only the first panel of the window gets broken when we press the button, so that's not what we want. But anyway, I forgot to use the query selector all property here. So that's why it only selected the first window pane. I'm just gonna replace the code here. And now we can test it. And as you will see right now, if we press the button, all the window panes will break. But we want them to break when the counter reaches 0, not have them break here. So what can we do to fix this? So if you remember, we have an onComplete function, which for now we have it right to the console animation complete. But we can also just copy this line of code here and paste it here. So in the onComplete function, when the animation will be complete, this will run. And when this will run, our gsap.to function will run, which will animate the window panes. I'm just gonna copy it again, repaste here, and publish the project. And now if we press the button, you will see that the counter runs, nothing happens to our window pane. Until it reaches 0, then all havoc breaks loose, and the window is gone. Now we can also have a message that appears here when the value reaches 0. For example, the timer can say boom. So how do we do that? Well, first we must hide this value since this is a number variable. We can't input text into a number variable. For example, we could set the var here to boom, but since the boom boom timer is a number value, we can't do that. So we need a text value. And I'm gonna create another variable, this time a text variable, and we're gonna call it boom 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 message. And the default value, let's leave it to boom, like this. And you know what, I just realized we don't even need the variable. We can just duplicate this, have it say boom, and just rename this to boom message. So we don't even need a variable for the text, unless you wanted to say something different based on a random number or whatever. You would need a variable, for example, if you wanted for when the timer reaches 300, another message plays. When the timer reaches 200, brace yourselves, please. But since we only want to have this boom message, we only need the text, not a variable. So another thing I'm going to do is I'm going to give this container for the variable, for the number variable, we're going to give it an accessibility property, and we're going to call it a boom container. So what we want is for this boom text to start out at the value of, with an opacity of 0, and then when we press the button, the animation plays, blah, blah, blah. When the counter reaches 0, this boom boom timer should disappear, so its opacity should be set to 0, and this boom text should appear again, and its opacity set to 1. So let's do this in JavaScript. So we're going to duplicate this. So we're going to call this boom message, and we're going to, I forgot what accessibility name we gave it. So boom message as well. Paste this in. So when the onComplete function runs, the boom message should appear. So I have a gsap.set here. .set. We're going to set the boom message. This is our animation target. We're going to set its opacity to a value of 1 because it will appear on the screen. Now all we need to do is we need to create a new JavaScript trigger when the timeline starts. So when the timeline starts on this slide, we have an execute JavaScript trigger that will change the opacity of the boom text to 0, so it doesn't show up on the screen. So let's put this in and write the code here. So I'm gonna get the, you know what, I actually made a mistake here because I shouldn't have gotten the boom message like this. I need to get it so it can be accessed by GSAP. So now I can get the boom message. So now I can get the boom message and set it into a boom message variable. So we are getting this here, and we're just gonna copy this function here and set its opacity to 0. So I'm gonna copy this into the trigger and publish. Now if we start the slide, the boom device is visible, but the boom text is not. Let's see what happens if we press the button. Nothing should happen because I didn't update the code in our execute JavaScript for the button. So let's do that. Check one last time. So we're gonna get the boom message, set its opacity to 1 when this onComplete function triggers, so when the animation is complete. And we're also gonna set we need to get another variable, which is the boom container. And we named it, let's just check to make sure, but we named it boom container. So I'm just gonna check that its accessibility value. It's a good thing that I checked because we named it boom container. So there you go. So now we're getting this as well. And we're gonna use the GSAP set function on it. So boom container, we're gonna set its opacity to 0. So now it should all work as intended. Let's put a semicolon here. So let's see. Just gonna copy this into the trigger for the button. And now I'm gonna hit publish. And the big moment is here. If I press the button, it should all work as expected. Let's see. So the timer goes down to 0. And our boom text appears. Our glass shatters. It's all working as we wanted. This is the code that made us proud today. If you've made it this far, congratulations. I hope these practices and examples are useful to you. Now, if you enjoyed this video, go ahead and leave a like or something. And yeah, good luck in your future projects using GSAP and JavaScript in Storyline.